So good morning everyone and welcome to this lecture. In this lecture we are going to deal with magnetic force. In the previous lecture we had seen the Ampere's law and we had found out the magnetic field due to a infinite solenoid, toroid, and we had seen some questions based on them. In today's class, we will move ahead and talk about force on a moving charge. So, the heading is magnetic force on a charge particle. Magnetic force on a charge particle. So, what we are going to have is we are going to have a charge particle, a moving charge which is moving, let us say a plus q charge moving with a velocity v, and this charge particle may be placed in a magnetic field. The angle between magnetic field and the velocity vector, as you can see, is theta. Theta is the angle between velocity vector and magnetic field. We can find out the force on this charge particle, and the value of the force is given by QVB sine theta. QVB sine theta will be the force on this charge particle which is moving inside a magnetic field. QVB sine theta. Now this QVB sine theta is going to give you the magnitude of force. This QVB sine theta is going to give you the magnitude of force. To get the direction of the force, we have to use the right hand thumb rule. Right hand thumb rule. How are we going to use the right hand thumb rule? We will come to that. This is the skill. This is the equation that gives us the magnitude. Yes. Any doubt? Anyone?
Sir, is this IIT class or NEET class?
This is NEET class. Have you come in the wrong room probably? I think this is the NEET class.
Sorry, sir.
Okay. So where we were, QVB sine theta is the equation that will give us the magnitude of this force. We will call it the scalar equation. If there is a scalar equation, then there must be a vector equation because force is a vector quantity. Q V cross B. That is the vector equation. The vector equation will give us both the magnitude as well as the direction of force, and therefore it is known as the vector equation. It gives us both the magnitude as well as the direction of force, so we call it the vector equation. This equation is the vector equation of force. The other one is the scalar equation. Now to find out the direction of force using the scalar equation, which is the equation that we are going to use, what we are going to do, is take the cross product of velocity of the vector with the magnetic field. So this right hand thumb rule, which is the cross product of this velocity with magnetic field, will give us the direction of this force. And remember, this will be the direction of force on positive charge. You can only find the direction of force on the positive charge. There is no way to find out the direction of force on negative charge. So if it is a negative charge, what do? You find the force, assuming it to be a positive charge, and then you reverse the direction of that force. We will do questions on this and try to understand how will I find the magnitude and direction of force. Right now, I'll give you 2 minutes so that you can write this part. Once you are done, please let me know so that we can move ahead. Okay, then let us move forward and see some examples where we find out the magnetic force. So this is the first question that I am going to give you. Now, I'll give that in vector form. So this is question number 1. A charge plus 2 microcoulomb is moving with velocity 2I in a magnetic field 5J. Everything is in SI units. Let me make this velocity as 4I so that all the things look say different. 4I hat in a magnetic field which is 5J. Find the force on the particle. So you have to find the force on the particle. I'll give you 2 minutes to give me the answer for this one. Let me know once you are done. Okay, so how are we going to solve this? First method, let me solve it with the vector equation. The vector equation is Q into V cross B. What I have to do is put the values and get the answer in this case. So the force would be charge is plus 2. So I write plus 2 microcoulomb. So the force will be in micro newtons. Velocity is given as 4I cross with 5J. So the answer will be 2 multiplied by 4 multiplied by 5. 4 into 5 is 20. 20 into 2 is 40. 40 wrong color. This will be 40. Now you have to do I cross J. You must remember I cross J is equal to K. So the answer is 40K. I cross J is K. So the answer is 40K. 40 is the magnitude and K is the direction. This is one way of doing it. I have done it using the vector equation. Now I will do it using the scalar equation. Scalar equation is you can get the answer by this formula Q VB sine theta. Now to just understand this, I will just draw the diagram of V. V is along I axis means X axis. So V is 4 meter per second like this. And your magnetic field is along Y axis. It is 5J. 5. This is your magnetic field and this is your velocity. The angle between them, as you can see, is 90 degrees. So I can now find out the force. Force is charge is 2. I will write it as 2. Velocity is 4. Magnetic field is 5. Sine of 90 degrees. Theta is 90 degrees. So I get the answer as 2 into 4 into 5. I get the answer as 40 micronewtons or newtons or whatever it is. Now to find out the direction, what I will do the cross product of V with B with my hands. So my thumb, the first vector will go in the direction of thumb. The second vector will go in the direction of palm. So I'll move my palm in the direction of magnetic field. This V cross B will give me the direction of the force. The direction in which my fingers turn will give me the direction of magnetic force. So this is velocity, it is along x-axis. Magnetic field is upwards along y-axis. So this is upwards, this is V, this is B, this is V, this is B, and I turn my fingers. This is V, this is B, and if you see, my fingers are pointing outwards. So the direction of field will be outward. Whenever I say outward, outward means the plus k axis. You look at the answer here, you look at the answer here, both the answers are same. Do we understand this, everyone? You understand this? Great. I'll give you 2 minutes to note it down. Once you are done, please let me know. I'll give you the next question. Let's move ahead and I'll give you one question to solve. This one, question number 2. A charge minus 5 coulomb is moving with a velocity minus 5I or minus 5J in a magnetic field B, which is along 2K. Find the force. I'll give you 2 minutes to solve this and get me the answer. So how are we supposed to do this? Again, first method, I will do it by the vector equation. Q V cross B. Remember here the charge is negative. So in the vector equation, if the charge is negative, you have to put it as negative. So this force ka vector becomes minus 5. Charge is negative, remember. V is minus 5J cross B is 2K. 2K. Now I can multiply. Minus 5 into minus 5 is 25. 25 into 2 is 50. Here I will get this as 50. J cross K. J cross K. I cross J is K. I cross J is K. And J cross K is I. So I will get this as I. The answer would be 50I. Do we understand this? If you don't know, you can note this down. I cross J is equal to K. J cross K is equal to I. K cross I is equal to J. If you reverse any of this, J cross I, it will become minus K. K cross J, it will become minus I. And I cross K will become minus J. This is how I can do it with the vector equation. If I want to do it with the scalar equation, let me first draw. This is your x-axis, this is your y-axis, and this is your z-axis. Your velocity is like this. Your velocity is in the upward direction. Oh, sorry, in the downward direction. I'm drawing it in the upward direction. So let me do it again. So your velocity is in the downward direction, minus 5. This is your velocity. Remember, the charge is also negative, minus 5 coulomb. Your magnetic field is coming out. Magnetic field, I can write it like this. Magnetic field B, which is given as 2K. Now, let me do it by the second way. I can find out the force Q, V, B, sine theta. Q here is given as it is given as minus 5. Do not use minus 5. If you use minus 5, you get the magnitude as negative. Magnitude cannot be negative. So we will use it as plus 5 only. Remember, in the scalar equation, we always use the positive value. Multiplied by the velocity is 5. Again, it is minus 5j, but I am using the magnitude. 5 into B is 2 into sine theta. Angle between V and B. One is along y-axis, the other one is along k-axis. The angle is 90 degrees. So I will get the answer as 50. This is the magnitude of the force. To find the direction of the force, I will have to move my thumb. Right hand thumb rule, V cross B will give me the direction of F. Your thumb will point in the direction of V. Your palm will point in the direction of B. And your fingers will tell you the direction of force. Velocity is going down, so this is downwards. Magnetic field is coming out, so this is coming out. See, this is your V. Magnetic field is coming out, and you can see my fingers are pointing in this direction. This direction is minus I. This direction is minus I. V cross B. This direction is minus I. That is the force on positive charge. But you can see here charge is negative. You can see here charge is negative. So it cannot be minus I. You reverse the direction. From minus I, it becomes plus I. So the force will be pointing here. You look at this direction or you look at this one. Both the directions are same. Do we understand this, everyone? Yes or no? Do we understand this? Okay, I'll give you 2 minutes to note it down. Then I'll give you certain examples so that you can practice. I hope you have noted this down. Then I'll give you certain examples and I will try to make you understand how to find out the direction using a right hand thumb rule. Let us take the first example. Let us say velocity is here like this and the magnetic field is going inside B, inside, and the charge, let us say, is a positive charge, plus Q charge. So how will I get the magnitude and direction of magnetic force? We can easily understand that force will be equal to Q into V into B. Here the angle is 90, so sine of 90. So force will become QVB. That is the magnitude of the force. To find the direction, V, B is going inside, P, B is going inside. The force will come on the y-axis. So the direction of force will be here like this. Your magnetic field, your velocity is like this. Your magnetic field is inside. Your force is coming on the top. Let me give you, first I will give you examples, then I will give you time that you can note it down. Now let me say that the velocity is like this. Magnetic field, let us take it like this. So the velocity is in this direction. The magnetic field is in this direction. And let me take the charge. Let me take the charge as negative now so that you understand how you find the negative charge force. Negative charge. In this case, how will I find? Force will be equal to Q into V into B into again sine of 90 because the angle is still 90 degrees between the two. So this force becomes Q into V into B. To find out the direction of force, again move my hands. V is going upwards. Palm is like this. It is in the x-axis. V is upwards. Magnetic field is here. And you can see where my fingers are going. My fingers are going inside. Inside means cross. So your force will go inside the board. But remember, that is the force on the positive charge. Charge here is negative. So you have to reverse the direction. So you cannot call it inside. You have to call it outside. So the force would be coming outside. Do we understand this? How I have done this? Yes or no? You understand this? Okay, I'll give you one more example, then I'll give you time to do it. Let me take one more example. Let me say that the magnetic field is like this. The velocity is coming out and the charge is a positive charge. A different combination. Let us see what is the force. Again, it will be QVB sine of 90 because the angle is still 90. Let me find out the direction of force. It's a positive charge. Velocity is coming out. So this is out. This is out. Thumb is in the outward direction. Magnetic field is along x-axis. So this is outward. This is along x. I turn my fingers. My fingers will go up. Going up means the force is in the upward direction. I hope you have understood how to do this. I'll give you 2 minutes to draw these diagrams and turn your fingers and get the direction of force. Once you are done, please let me know. I hope you have noted this down. Let us then move ahead and write some important points about this force. Important points. Number one, if I write the force is Q into V cross B vectorly, or I can write this force in the scalar form Q V B sine theta. This force will be 0 if Q is equal to 0. That is the first point. If there is no charge, obviously there is no force. This force is again 0 if the magnetic field is not there. So if there is no magnetic field, obviously there is no magnetic force. The next point is an important one. This F is 0 if V is equal to 0. This F is equal to 0 when the velocity is 0. That means if the particle is at rest, if the particle is at rest, if the particle is at rest, it will not experience any force. A very important point. If a particle is at rest, if a particle is at rest, it does not experience any force. That means magnetic field or magnetic force cannot start the motion of a particle. Magnetic field cannot start the motion of a particle or stop the motion of a particle or stop the motion of a particle. Magnetic field cannot start the motion of the particle or stop the motion of a particle. Do we understand this? If a particle is at rest, if a particle is at rest, it will remain at rest. Do we understand this? Yes or no? Do we understand this? Yes or no? I'll give you 2 minutes to note it down. Okay, then let's move ahead. The next point is if theta is equal to 0 or 180 degrees, then also the force is 0 because sine of 0 or sine of 180 degrees is 0. That means a moving particle, even if it is moving, it has a velocity, it will not experience a force if it is moving parallel or anti-parallel to the field. So this is the case if the particle is moving parallel or anti-parallel, parallel or anti-parallel to the magnetic field, the force is still 0. The force is 0 if the angle is 0 or the angle is 180 degrees. If if theta is 90 degrees, force is maximum, and this maximum force will be given by QV into B. If the angle between V and B is 90 degrees, the force would be maximum, and the maximum force would be given by Q into V into B. If the angle theta is not 0 or 90, then the force is, if the theta is in between 0 or 90, then the force becomes QVB sine theta. Do we understand this? Yes or no? We understand this? Yes or no? If the angle is between 0 or 90, the force will become QVB sine theta. So if it is 0 or 180, the force is 0. If it is 90, the force is maximum, which is this case. If the angle is between 0 and 90, this is the case. I hope we understand this. Yes or no? No or yes? I'll give you 2 minutes to note this down. Okay, then in today's class, what we have done is we have seen the force on a charged particle and we have seen some important points about this force. 1 or 2 points are still remaining. We will come back to those points in the next class and we will discuss those points in the next class. That would be a revision of today's class as well. This is the most important aspect of this chapter. The important points about force, because these are the questions that come in the exam these days. So I'll get back to this one and we will discuss more points on this force in the next class. So see you tomorrow, same time. And I hope you have noted this down. Do you have noted this down, everyone? Okay, then we will go ahead from this point on in the next class. Take care. God bless you all. Bye bye. Have you understood what we have done today? Okay, beta. Take care. Good day.